So it's possible to use the skills that you use in physics for other jobs too. Alright, it's possible, but what did they really do? So what did the class of 2009 and 2010 that got a bachelor's in physics do with it? Okay? So here is a statistics that shows that 53% of them went to the private sector. What does that mean? That's engineering jobs, computer science jobs, and so on and so forth. I will say that my husband, for example, has a master's in physics, but now he's a very successful computer scientist. So, people do a lot of career changes. And some of these people can go to colleges and universities, like I did, continue to do research and get a doctorate degree. And some of them decide to share their passion with physics, like your teachers do, and pass it along to the young generations. Of course, you can also opt to work in a national lab, and so on. And they also give you some kind of an indication of what the starting salaries would be. And they also have statistics on the gender representation in physics. And I chose this one here that shows you, in a university department of physics, you'll find only 20% to 25% females in the professorships. And that's pretty low, and that's not a surprise. So as I got my education in physics, during college, there were 9 guys and I was the only girl. During PhD times, there were 20 guys and there were 2 girls. So it's not a surprise that you sit in a classroom like this and you will be the only girl listening to that course. But that's okay. That is not a problem. So those guys were my lab mates and it was the best time ever. So I don't find that a problem. And I think that having more girls interested in science is hopefully going to help us taking, those statistics from 20% all the way to 50%. I hope you and me are going to be some of those girls to fill up those statistics. All right. So how is it like to do a major in physics? How is it like to go to college and do physics? So I thought about it to compare it to you guys with a sport like snowboarding, right? Or I'm sure many of you take dance lessons or, music instruments. It's fun, but it's challenging. It's not easy to do it. You need a lot of practice. You go to a lot of practice. It's the same for physics. The point is that challenging part, you gotta love it. So it's the same. So in physics, what was it most fun for me? Well, I love that I can understand, after my courses, I could understand the science behind the gadget. So I could understand how my cell phone works, and I could understand how things around the house work. But it was challenging. Advanced maths needs a lot of practice, and a lot of practice. And I cannot stress this enough, that math is probably something that you should take most seriously. It's something that builds on from one class to another, and it's really crucial that you sort of go along with it. So keep calm and do the math every year, every semester. So another very important thing in college was for me to do internships. You may think the job is cool, but it's worth giving it a shot. So what I did is I actually went and tried to do research. I also tried to do something more industry-related when I was in college. Just for a month or for 2, when you have a break, you can do a small internship, paid or not paid. And that gave me a sense, and then I asked myself, do I want to do that for longer? And if the answer is no, then that's not the right thing. And so what I decided was that research was what I wanted to do, because that summer that I spent in a research lab, in a research group, was the best time I had in college. Now, grad school was taking this to a whole different level. It was less homework and more research. But what does research mean? Well, now you're working on problems that nobody knows the answer to. And that's hard. Not only you have to find the answer to those problems, but you have to convince the people around you that you found the right answers. So that's why the PhD experience is very long, but it's a lot of fun. It's a lot of discovery. It's you using the fanciest tools that technology has to discover things that could be the next best thing. And that's very, very exciting. So what do? We solve problems. We innovate. We find new materials. And we answer questions, as I said, that nobody knows the answer to. And some of them are addressing very basic and very fundamental things about our world. Like, what is the smallest particle? Why is the gold your gold necklace that color, or things like this. And if there's one thing I learned in grad school, is this quote pretty much summarizes it, and it says, "Ever tried, ever fail, no matter, try again, fail better." And what that means is that you should never give up. You should try things out and learn from your mistakes. And you're very likely gonna fail many times, just like with snowboarding, right? You fall many times before you really learn how to use it. But the key part is to learn why you made that mistake and try to never repeat it. And this way you sort of try to grow. Okay, so I'm a physicist, so what kind of problems do we learn about in physics? So there are people who do so-called particle physicists. Actually, Lauren here does that. And what they wonder about is, what are the smallest components of the universe? Is it something smaller than the electron? And so on. That's the kind of questions they answer. Well, then the astrophysicists, they just look up the sky and then they say, what's beyond our planet? What are all these stars made out of? And then they go to the big telescopes and they try to answer these questions. What was for me most interesting are questions related to things that we touch every day, to materials.